Welcome to this video from In 28 Minutes. Thanks for helping us provide awesome learning experiences to more than 300,000 learners across multiple platforms, Udemy, Safari, and Pact. Let's welcome our lead instructor, RANGA KARANAM. We are now in part 3 of this 3 series of videos on microservices. In the first part, we introduced you to microservices. In the second part, we talked about the architectures. Now, we are focusing on best practices. We'll be talking about why do we need to use queues in microservices. We'll talk about the importance of automation testing for microservices, as well as we'll talk about a couple of important concepts called eventual consistency and archetypes. I'm excited to bring this to you, and let's start with the first step. Welcome back. When you look at a lot of microservices architectures, you would make extensive use of queues. In this video, we'll talk about why is a queue needed. We know that with queue, you would be able to use something called asynchronous messaging. Why is asynchronous messaging important? What are its advantages? Let's look at that in this specific video. Let's consider a simple example, right? So we have an order service. So basically a customer places an order through the order service. And what are the things that we would want to do when we receive an order? We would want to update the stock. We would want to send an email to the customer. We would want to send an SMS to the customer, as well as we would want to start informing the packaging and delivery team. So those are the important features that we would want to accomplish. One way I can do that is to design one component which does all these stuff together. So I write a simple Java application where as soon as the order button is clicked, I update the database, I send an email, I send an SMS, I send a request to the packaging service. The other option is to have a queue in between. So whenever an order service receives an order, it places it on the queue, and you have independent services listening on to the queue. As soon as they see the order event, the stock service takes the data from it and updates the stock. The email service looks at it and sends an email. The SMS service looks at it and sends an SMS. And the packaging service looks at the order and it creates all the stuff it would need to initiate the packing and delivery request. So these are kind of the two architecture styles that you can use to achieve this functionality. If you are a small organization receiving hundreds or thousands of orders, then having a simple application architecture might be a very good choice for you. But when we are talking about a large scale, let's say I'm talking about Amazon receiving millions of orders, you would want to have a lot of flexibility. And that's when you would go for the second kind of architecture where you bring a queue in. Now, I have not really answered the question, what are the advantages of having a queue in between? Let's start with one of the scenarios. Let's say the SMS service is down for a little while. It's down for a few minutes. And if the order service is directly calling the SMS service, what would happen? You will not be able to send the SMS. And that means you might want to cancel the order because all these things might be in a single transaction. So in a simple application, let's say the stock service was not able to update the order for a little while, or I was unable to send an email, or I was unable to send a service request to the package service. If I was doing it synchronously through a small web service call or directly inside the application, then what would happen? What would happen is that the order request would fail and we would ask the customer to reinitiate the request. We might need to say try after a few minutes, try after 10 minutes and things like that. But when it's asynchronous, all that the order service needs to do is put a request in the queue, and whenever the SMS service is up, it would listen to that particular event and it would send the request out. So the most important thing is it's more reliable, because even if one of these services are down when you receive the order, as soon as the service is back up, they can take the message and process it and make sure that everything is running fine. The other important thing which it provides is scalability, right? If you have all these done by the same server, let's assume that on a specific day you'd want to send 100,000 SMSs. You know that you are going to send a lot of SMSs or a lot of emails. What I can do is I can increase the number of instances of the SMS service or the email service, so that whatever messages come in, I would process them very quickly. With the queue architecture, I would have that flexibility. I can create as many instances of these individual services as I would want, and I would be able to easily process the different things that are present in the queue. The third important thing is it's easily testable. Each of these services have independent requirements, and so it's very easy to test each one of them. And obviously it's more maintainable because this would be smaller applications. So typically we go for queues in our architecture when we would want huge amount of scalability. Small applications, you might want to keep the architecture simple, but when we are talking about applications which serve millions of users, you'd want to use event-driven architectures based on the queues. Some of the popular queues are RabbitMQ and Nav, Kafka. These use varied kinds of protocols, but the important thing is the concept remains the same. A queue helps you separate the thing which is generating the event from the services which are processing the event. The services which are processing the event need not be available all the time, and in case there is huge amount of load, you can increase the number of services which are processing the events very easily. The other flexibility we get is making changes is very easy. So in addition to these, let's say I would want to do something else, then I would not need to touch any of these services. I just need to create a new service which is listening on to the queue for the specific event it is interested in. All these features makes it imperative that whenever you have requirements of processing things from a huge number of users, you would want to typically go for architectures involving queues. In this video, we would be talking about something called eventual consistency. Whenever we talk about microservices architecture, we would want to have eventual consistency. What is that? Let's focus on that in this specific video. Now, whenever we go for microservices architecture, you know that we would have a number of smaller microservices instead of larger single deployable application. So we would have a number of microservices, and one of the things that we would use to market the microservices architecture is to say, I can have microservice 1 in Spring Boot, microservice 2 in Node.js, microservice 3, let's say in Python, and different architectures for microservice 4 and microservice 5. The thing is, that's not really a good situation to be in, because if you have different architectures for each of these microservices, what would happen is it becomes difficult to maintain them. The kind of themes you need to maintain microservice 2 is different from microservice 4, and that's a big headache that you would not really want to get into. Now, it's very important that you have the capability to innovate, right? So if there is a new framework out there which you think is good, you'd really want to try it. So in that sense, a microservice 5 might be using a new framework which is a little different from microservice 1. But that should not mean that the microservice 5 is completely different from microservice 1. One of the ways you can do that is by having a standard reference architecture. So whenever you have a microservices architecture being used, then you should have a reference architecture which says this is the standard way of doing things. Whenever there is something new comes in, you would evaluate it and you would check whether it suits our specific needs, whether it's something you would want to give it a try, and then you would find the right place where you would want to implement it, specific microservice, implement it, try it out, and if it's good, then you'd kind of bring it into the microservices reference standard. And that's how you would ensure that microservices are eventually consistent. There might be a small amount of variation in all times because you'd want to always keep innovating. You'd want to try new frameworks, new languages, new protocols, or new ways of communicating. So you'd always want to keep trying out new stuff, but one of the most important things that you need to make sure is that you are clear about what are the new things that are being tried out. You have little bit of governance around it, and at all times you are trying to have as much consistency as possible. It's a difficult balance to find because you would want these microservices to be consistent, but you would also want to keep innovating, and that's where the eventual consistency comes into picture. So you try new things and you would bring them. In this video, we'd be talking about why you would want to be able to automatically create your microservices. Why do we think that having a great archetype is very important for success of microservices architecture? Why do we think having a reference architecture is very important for the success of microservices architectures? One of the most important things that we discussed earlier is the fact that with microservices architecture, we would have a small microservices, a number of sets of them. So you would not have one big application, but you would be creating a number of microservices like this. And one of the important things that we talked about is the fact that these microservices, you want to be able to create them very fast. The other thing is all these microservices should be uniform. When a developer moves from microservice 2 to microservice 3, he should not see a huge difference between how they are working. The business functionality will be different, but technically speaking, the frameworks which you use, how you do unit testing, how do you do integration testing, how does it integrate with the naming server, how does it integrate with the API gateway, those things should not change. And that's where the reference architecture for your microservices comes into picture. Having a great reference architecture would help you in making sure that all the microservices are uniform. And one of the ways you can standardize your reference architecture is by creating an archetype. What is an archetype? An archetype is nothing but a piece of code, a component which can create all the technical infrastructure that is needed to set up a microservice. So what would the output of an archetype? Would be a new microservice with all the frameworks set up, with all the examples for unit testing, for examples for integration testing, examples for how to talk to the naming server. All of them are set up, and all that you need to do is to start developing your business functionality. So whenever you'd want to be able to develop a microservice, all that you need to do is go to the archetype, and you would actually create a microservice using the archetype and start working on it. One of the things I have done a little while back was I created a microservice reference archetype. We have a GitHub repository. In 28 minutes, microservice reference archetype. You can see the URL on the screen right now. So all that you need to do is type in that, and it would take you to an example microservice archetype. As you can read in here, my archetype helps in automating the basic setup of a microservice. This helps in standardizing project setup across the organization. How many layers you should have, which layer should be dependent on which layer, how do you do security, how do you do unit testing, integration testing, how do you integrate things with Nexus or Sonar. So all that kind of stuff can be put in as part of your microservice archetype. I also included a reference to the Marvin archetype plugin so that you can find out how to use archetypes. But what you can do in here is discover how you can set it up, how can you use this archetype as well. What I have done is there's a microservice reference. That's where the complete reference microservice is present. And in this application, we have a couple of controllers, and also we have a couple of examples of unit test and integration test. The first thing you need to do is to clone or download this thing, and you can actually do a mvn clean install at the root of that specific folder to install the to install the microservice archetype. And once you do that, you can go to the microservice you can cd to that folder and actually use the archetype. So you can say archetype create from project. You can enter a group ID, a artifact ID, and you can enter a version, and you can use the package structure. What it would do is it would actually create the project completely. So it would create a new project, and you can do an mvn clean install, and also you can do a file import as Maven project into Eclipse, and you can try and play it out. So it would have a complete infrastructure that you need to develop a typical microservice along with it. In this video, we talked about an archetype. Why do you need to have an archetype when you're using microservices architectures? Why do you need to have a reference architecture in place? A reference architecture would help you in deciding what all microservices should do. How should their architecture be? How many layers? How should you do unit testing, integration testing? How should you use in-memory database? How should you connect to the naming server? How should you connect to the API gateway? And all that kind of questions are typically answered by your reference architecture. And you can have an archetype to implement an example application that adheres to the reference architecture. Whenever you have a need for creating a microservice, all that the developer should do is to go to the archetype and create a new sample application. That would ensure that there is consistency among all your microservices, and also the developers get to focus on the business functionality and not really focus on the technical infrastructure that is typically needed. In this video, we would be talking about why automated testing is very important in microservices architectures. As we discussed in a number of videos, when we go for a microservices architecture, we would have a number of smaller microservices. Instead of having one big application, you would have a number of microservices which are independently deployable. You'd be able to take microservice 3 live without making a change to any of the other microservices. One of the reasons why you'd want to go for a microservice architectures is faster release cycles. Is basically business innovation. You'd want to be able to release new features and get feedback from your users very fast. How fast you can take your new features live is one of the most important success factors in these competitive days. If your competitor can take features live much faster than you, then he has a big advantage, and that's why you'd want to release things much faster. What are the most important things to be able to release things very fast? You need to be able to test things fast. You need to be able to guarantee the reliability of your application. Now, how do you guarantee the reliability of the application? It's by testing the microservices much faster. Now, if you are depending on manual testing, will you be able to test everything fast? The answer to that is no. If you are using manual testing, can you guarantee that everything is working? Sometimes the answer is no, because while doing manual testing, people might make errors. So automation testing is more reliable and also it is fast. And that's the reason why automation testing is very important when it comes to microservices architectures. Microservices architectures is based on lot of moving components. You have a lot of small microservices instead of a large application. And if something is wrong, you'd want to find that out immediately, and that's where automation testing comes into picture. Now, what are the various kinds of automation tests that you can have in a microservices architecture? Each of these microservices can have unit tests. If you are using test-driven development, it would help you with having great design, great design at the low level, as well as it will help you with having great unit tests. So that's number one, unit tests inside these microservices. Unit tests are basically things which would test specific features in a specific class. So if you're talking about Java, you'd have a number of classes inside your microservices. So each of these classes, maybe even each method in those classes has great unit tests. So that's the starting point. The second important thing is to have layer integration tests. This microservice 1 might have multiple layers. Are the layers combining well? So that's the layer integration test that you can have within each of these microservices. The third thing you can have is API tests. So this microservice 1 is exposing a set of APIs, is exposing a set of services. We can write automated tests talking to them. One of the most important thing when we talk about automation tests at an API level is to make sure that your data which is behind these microservices, which the microservice needs to be working does not really change. You can use things like in-memory databases. The fourth kind of automation test that you can do is complete integration testing around all the microservices. So this microservice is calling microservice 2, microservice 3, and microservice 4 and microservice 5 before getting the complete response. So you can have an automated test which deploys all these microservices and test them whether they are all integrating really well. So what we are talking about is really multiple levels of automation testing. We started with unit tests at the basic level, layer integration tests. We talked about API tests. We talked about combined integration tests along these layers. And the last one, which you can also have, is user acceptance tests, which are automated. So in your user acceptance test environment, have automation tests around all the tests that your users would typically do. One of the most important things around automation tests is to have great debuggability, right? So if an automation test fails, then you would want to be able to debug it very fast. And for having great debuggability, you need to have great visibility into what's happening behind these microservices in each of these environments. You don't want to get into a situation where if there's a flaw or if there's a test failure, you need hours and hours to debug. So it's very important that you have great visibility built into all the microservices and be able to debug problems much faster. In this video, we looked at what are the different automation tests that you can have around your microservices, as well as how you can make great use of them. I'll leave you with a last tip. It's to make sure that as many of these automation tests are included in your continuous integration. Continuous integration is a great thing, and once you have all these unit tests, automation tests running in continuous integration cycles, whenever you have a problem, you will find it out earlier. I hope you had an interesting time watching this video on microservice. The idea behind this video was to give you a theoretical overview around microservices, but if you are interested, then you can check out our course on microservices. You can take the link to the GitHub repository and search for microservice, and you should see an awesome course helping you build a microservice with Spring Boot and Spring Cloud. In 28 minutes is providing awesome learning experiences to 300,000 learners across platforms like Udemy, Safari Online, and Pact. We have clocked million hours of learning in the last few months. The question is, what do you want to learn next? We are building solutions to help programmers at all levels. You can learn programming with our awesome courses on Java, Python, and JavaScript. You can learn full stack development with REST APIs and microservices with a wide range of frameworks like Spring Boot, Node.js, React, Angular, and Spring Cloud. We have 200 plus videos to help you start your journey from a programmer to a software architect. We have videos to help you learn frameworks, industry trends, including things like microservices. Learn the best practices in architecture, design, and code quality. Thanks for watching. Keep learning in 28 minutes.